there's 24 GPIOs on the silicon in addition to the 8 MOSFETs that we've discussed. These 24 GPIOs are both analog or digital, and by context they will take on the appropriate personality. So if this done signal is a digital signal, I can go ahead and drag and drop that to any pin here. The feedback signal is an analog signal, so I can drag that to a pin, and that pin will automatically become an analog pin. I can either have this power component be enabled from a GPIO pin, always be enabled, or I can have it enabled from the sequencer. For this example, I'm going to enable it from the sequencer. The sequencer is an event-based sequencer, so it will take in the power good signal from the power component to tell it when to advance. The way the sequencer right now is set up is if I leave this wire hanging, the tool will automatically assign a GPIO pin for that signal. Right now, I'm going to delete that wire, and I'm going to go ahead and come in here and right-click the on signal and say set it to high. So internally, as soon as configuration completes, this pin, this enable signal will go high, and it will start the sequence out automatically. So it's literally this easy to custom configure your GPIOs and your pinouts and compile the design based on that. Each of the GPIO pins has various different settings you can set on it. So I can set a pin to be tri-stated, high or low, or I can then take a pin that has a signal going on it and I can choose how that signal behaves. So I can put a pull up on it, a pull down, or set it as an open drain output. So this is different for pins that have a signal versus pins that do not have a signal. And then if something I accidentally set it, I can remove the IO state and have that signal go away and be driven as a push-pull output as a standard digital signal would be on a pin. So there's a lot of flexibility in setting these GPIO settings as well.